Oh, there's an Amazon guy backing down the driveway. Not too long ago, I watched a FedEx delivery guy after dropping something off for my neighbors hit the neighbor's basketball hoop. It was pretty funny.
Are you telling me that I need to build a little basketball hoop and then like have a big arrow that points like, UPS drivers so they can like dunk my packages?
Yes, that would be great.
They're already chucking them anyways.
Yeah, exactly. I'll just make it more fun.
There she is.
Hey y'all.
Hi.
I'm sorry about that.
It's okay. Let's get started. Brian, take it away.
Okay. Hey everyone. I'm Brian. Today I'm going to talk about the design process. Just as a heads up, I was kind of short on time putting this together, so if there are any hiccups, I apologize. We'll work through them. And if at any point, if you have any questions, feel free to just speak up and stop. So let's get started. So first, a little bit about me. So I am a full-time engineering aide at Lockheed Martin, and I'm a part-time mechanical engineering student at UW-Bothell. So I spent, in terms of my background with designing things, I spent 4 years on a FIRST robotics team in high school. So for that, every year, it's a global robotics competition. Every year we get a new design challenge, which it's a game that ends up playing sort of similarly to a sports competition, but you get 6.5 weeks to design, build, prototype, test, and complete a robot. And it's a totally different robot and game every year. So I got a lot of experience with rapid prototyping there, and then integrating the different design phases. During my freshman year at UW, I also worked on a research project where we developed a 3D printable prosthetic arm with the goal of it being globally accessible, cheap to use, and easy to modify as well. So it was all open source. And then after that, I started the Trickfire robotics team at UW-Bothell and led that for 3 years. So there we competed in the NASA robotic mining competition. Our goal there was to design basically a Martian rover that had to traverse a field with the same simulated Martian regolith or lunar regolith that NASA uses for their actual robots. And we had to be able to dig and collect ice samples. So yeah. So first of all, what are the steps of the design process? This is a question I'm asking you guys. What are the steps? Oops, that one. Slide. Name them out. Any order, doesn't matter.
Ideation.
Sketch.
Okay, we got sketch, we got ideation.
Prototype test.
Yeah, I'm just gonna listen to this. Ideation, yeah, brainstorming, you said prototyping. Sketching, yeah, that's actually important. That will go in, yeah, we'll say, I can spell. Okay. Okay. Anything else?
You got to test your prototype and review the data.
Okay, we'll merge that in with, I'll leave that as a subsection of prototyping. Anything else? Are you gonna have to, are you 3D modeling at any point? What are you doing after that?
Oops. There's definitely some CAD.
Cool.
And
Do you ever assemble anything?
we'll go back and iterate as you come into problems as well.
Yeah, that's, yeah, part of the process there.
Analysis.
Analysis, yes.
Figured assembly was part of prototyping.
Yeah.
Yes. Let me think here. It's, okay, we'll write an analysis. And actually, I guess, so that actually, thinking about this now, it sounds like you guys have a better idea of this than I was initially anticipating, which is great because it's easy to get into the idea. The point here is that it's not a linear process, and a lot of people tend to think that's the case. So like, for example, with something like testing or analysis, that's not really one thing you can fit into one category. It's kind of all over the place. So that's awesome. That's important to realize. We're gonna flip this. Nope, there we go.
Did you tell them we were dumb or something?
No, I just wasn't sure. Oh, great, thanks Windows. Yep, 1 second. Sorry about this. display settings, switch. There we go. Okay, too much work. All right. No, I just wasn't sure what experience you guys had with this sort of thing. So this is just sort of an easy way to gauge that, just so that I don't accidentally spend, a ton of time explaining something that's already obvious to you. So cool. Yeah, so as you guys already know, it's not really a linear process. So we're going to kind of go through step by step. The general idea is it's not going to look exactly the same every time. But my goal here is to hopefully give you a good enough understanding of the ideology behind it and some of the pitfalls you can fall into so that you have enough information that you can apply this to any situation. And so for part of that, we're going to look at an example problem, which is to create a robot that shoots basketballs into a hoop from a fixed position with 80% accuracy or better. So step number one, actually, before we get to step number one, we have to do a couple of pre-steps. So there are 4 important things that you need to do before you even get to any point where you're coming up with ideas. And the first thing, the most important thing, is to assign a project manager. And the reason you need to do this as soon as possible is because as you're dissecting the project requirements and brainstorming ideas, you need someone to help guide those discussions. It's pretty easy to get into a situation where you spend, 15 or 20 minutes talking about one specific detail and get like really nitty gritty into it. And you need someone to say, hey, we just need to go with this and move on. They're also going to be in charge of tracking the master schedule, making a call when there's an impasse, like I was saying there. And this person can still have other roles within the project, just so long as the project isn't too complex. If you're designing an entire space shuttle, chances are their project management is going to take up a lot more of their time. The most difficult part of this, though, and the most important part as well, is being able to distinctly separate, as a project manager, your own opinions from guiding design discussions. And that's really tricky to do. When you're in the brainstorming phase and you're trying to decide what to go ahead with, it's really easy for you to think, well, I like this design. I think we should go with it. But you need to separate that and also be able to do that in a way that doesn't really imply that you personally think this is the better design. So it's tricky, but you need to make clear why this is what we should go with, as opposed to, I think this is what we should go with, and that's why we're going with it. So next step is to assign a meeting note taker. And this is going to be someone different than the project manager, but this is a really important role because you need to document things. When you get to the end of your project, you're probably going to have to write a paper or come up with some sort of presentation. And it's way, way easier if you have someone who's been taking notes about everything, because if you get to the end and you need to justify why one part was, why a bracket was 6 inches long instead of 8 inches long that you designed 4 months ago, chances are you're not going to remember. But if you've got someone taking meeting notes, you can go back to that meeting and be like, oh, okay, that's right. We had this discussion and we decided it was this size for this reason. Yeah, and they're also going to be taking notes during prototyping, testing, brainstorming, basically any sort of meeting. And if they can take pictures, that's great too, because pictures are also really nice for presentations and documentation. Next, you have to make a schedule. At this point, you're not going to know all of the details.
Hey, Brian,
but it's
your
important.
slides supposed to be changing?
Oh, they are.
Because I've been hearing you click when you move on to a new subject. We're still on the basketball.
Yeah, you're right. I can see that now. 1 second. That's weird.
The cute robot.
What happened there?
I thought this was
Okay,
all
well,
the example.
let me try this instead. Share screen. Actually, I'm just gonna, yeah. Sure. All right, you won't be able to see my face anymore, but that's okay. At least you can see the stuff. If I switch the screens, can you guys see everything now? Okay, you can still see the robot. Can you see another slide now?
Yes.
Yep.
Okay, cool. Perfect. Okay. Sweet. So now, step 3, create a schedule. Like I said, you won't have all of the nitty-gritty details at this point. That's totally okay. The schedule isn't going to be set from the start, but it's important to set up your major goals throughout the project at this point, because if you don't, it's going to be really easy for you to accidentally not leave enough time at the end for testing or for a different step that you didn't realize you needed to take care of. But at this point, you should be able to define some of the major milestones. So the start and end of each of the design phases, the completion of design for specific sub-assemblies, a deadline for having parts ordered to make sure they arrive on time, a deadline for having project reports or draft presentations or final copies due. Yeah. And the last part is going to be to schedule weekly update meetings. And the point of these meetings these meetings specifically, they're not design meetings. It's more for the sake of documentation, getting everyone up to speed. So each sub-team lead or team member, if you've got a small team like in this case, they're just going to report what you did in the previous week, what you're going to do in the next week, and discuss any scheduling issues that haven't already come up. And that's it. It's, like I said, just to catch everyone up and make sure everyone knows what they're doing in the following week. And this is a great time to take a look at your schedule and figure out if you need to make any schedule updates. If you do happen to have any design discussions that you need to have, save them for the end, just to get this out of the way. But the other point, or the other reason not to make the focus on design for this meeting, is if you have something that you need to talk to someone about, you don't want to make it a habit of waiting until the weekly meeting for that. You'll probably need to talk to them sooner about that. Cool. So that being the case, it's time to identify the design requirements. So you're going to want to start with things that are pretty obvious. And we'll look back again at our example here. We're going to create a robot that shoots basketballs into a hoop from a fixed position with 80% accuracy or better. So given that, do any of you guys know, or can any of you guys tell me any design requirements that we already have here?
Actually, you're going to need to be able to actuate the arms to shoot a basketball is pretty significant.
Sorry, say that one more time. Actuate arm?
Yeah, we're going to need to be able to shoot the basketball in some way.
Okay, there you go.
That's rather significant.
Okay. Are there any more specific requirements for shooting the basketball, or can we just shoot it anywhere?
80% accuracy. And it has to be from a fixed position. It has to actually land, that accuracy has to land in a target. It's to hit the hoop with 80% accuracy.
Yeah. Oh, I see. There we go. That's good to add. Shoot basketball. There we go. Anything else so far?
Needs to be strong enough to not tip over, or it needs to be strong enough to withstand the forces. Well,
Okay.
Yeah, it doesn't want to tip itself over, shoot it, and fall back.
Yeah.
Bad.
Awesome. Let's just do one more here.
It needs to be able to define the target or know what the target is. I guess that's part of 80% accuracy.
Yeah, that could lead to another interesting thing. So that's the I guess item of interest there is it needs a way. How do I phrase this? Well, so there are multiple ways you can approach it, right? You can have it.
It's not necessarily computer vision.
Yeah, because so that I guess the question there is, does it need to be able to find the hoop, or is it going to always be from the same distance? At this point, that's not specified, so you can figure out what you want to do with that. So that actually leads to a different part of this. So for any requirements that aren't explicitly set by the problem, it's best to just set something that is it's as easy to meet as possible without hindering your actually important requirements. So in this case, problem doesn't say that we need to be able to find the hoop, right? So why not just set it from a set position every single time? That makes it easy to make sure that we can hit the hoop with 80% accuracy. It makes our design more simple because we don't need to come up with some sort of vision or hoop tracking system. And that's just going to make it a simpler problem overall. And that's something that's important to remember. That said, of course, you don't want to make it too simple. In some cases, you can hinder the problem as well if you make that too simple. So back to the other requirement we already said here. So withstanding the force of the basketball being shot without breaking or falling over, those aren't things that were explicitly set by the problem. But if we set those bars too low, we might not be able to actually shoot the basketball to begin with, or the robot might fall over. So yeah, and then so we covered the obvious given parts of the problem pretty well, but it gets kind of tricky to figure out some of the other things that aren't obvious. For example, you need to figure out, if there's an electronic system, you need to figure out the power, to figure out your requirements for that. Do you want this to be battery powered? Do you want, are you okay with having it plugged into a wall, that sort of thing? So when you're going through that, it helps to think about what potential subsystems your robot's going to have. So for example, there's the electronic system. So then you need to think about the requirements for that. In this case, you have some sort of shooting mechanism. If the problem required that the robot move around, then we'd have a separate system for a drivetrain. And then on top of that, we might need to have some sort of, hoop tracking system. So separating or thinking about the potential subsystems that you have can help you try to figure out some of the requirements that aren't obvious to the problem. So you can define those earlier on. And that said, there's a good chance you're going to miss some things. That's totally okay. You can always come back when you realize, oh, we forgot to think about how we want to control this and requirements for the control system. You can always come back to add those in later. So next, it's doing the thing again. Okay, there we go. So next we're on my favorite part of the design process, which is brainstorming. No idea is too stupid here. And I really like to encourage thinking outside of the box, because a lot of the time something that you think is completely ridiculous as an idea actually ends up being a great idea. And as an example of that, so one of the years in the first robotics competition, the basic idea with the game that year was you had to build a robot that would drive around a donut-shaped course, and then it had to pick up this giant 5-foot diameter yoga ball and then throw it over a bar. And every time the ball went over the bar, you got a point. And every time you went a lap around, you also got points as well. So most of the teams ended up with big robots that could carry the balls, go around the course, shoot them over. But one team decided, they did some math and figured out that instead, if you can build a robot that is small enough and fast enough, you can do enough laps to actually outscore all of the other robots. And that's something that someone might suggest is just like kind of a silly idea, but that team won the competition that year. So yeah, I really like encouraging thinking outside of the box. No idea is too stupid. And part of what helps with that is trying to set a minimum number of ideas for each team member to come up with. And the reason for that is you want to set it to something so that you kind of have to think to come up with those last few ideas. So you might come up with something that you think is going to be a terrible idea, but you have more ideas to work with, and it helps give you context for things. So you want to set that number to something that makes you think a little bit, but not so much that you spend an entire week just to come up with your one final idea. Other thing is, at this point, you should try not to have your ideas tied down to specific mechanisms unless it's absolutely necessary. So what I mean by that is, say with the basketball or the basketball shooter here, if one of the ideas is to have a flywheel shooter, so you've got spinning wheel, ball makes contact with the wheel and it launches it. The idea should just be the flywheel shooter and not a flywheel shooter with a belt drive or a flywheel shooter with a gear-driven system or something else like that. And the reason for that is it gives you more options later on when you're thinking of how you want to prototype things or how to merge the ideas together. Other thing to note is that the ideas can solve all or just a few of the requirements that you need. So if hopefully that makes sense there. Right, and then once you have all of your ideas down, try to group them by the different requirements they address. This will help you once you're actually comparing your ideas. That way you know what to compare to what. With the case of the basketball shooter, since it's a fixed position, there's probably not going to be too many different subsystems, but say if we had to make the basketball shooter drive, you'd probably have one set for drivetrain ideas and another set for the actual shooting mechanisms. So next step from there. So the scenario now is we came up with a bunch of ideas and we have a few candidates that work well. How is this slide clicking? There we go. Okay. How do we pick the ones that are better? I'm asking you guys now. We've got a bunch of ideas. How do we pick the ones that are better? How do we figure that out?
It is a white slide.
Puke chart.
It is, I know.
Trade study.
Trade study. Okay. What did you say, Allie?
Puke chart.
Cube chart. Was there something else?
It's
someone
about the
else said
same.
to? Okay. Anything else? Cool. Yeah. Okay. So you've got the right idea there. Yeah. You need some way to actually score your ideas. So those are some methods. Depending, and this is another thing where this will totally depend on what the context of the problem is. In some cases, one option might be better than another one. If you have no idea how to proceed, though, one thing that you can do is assign a value from 1 to 5 or from whatever scoring system you want for each relevant requirement for every idea. Have each person do that, take the average. The important thing here isn't to get a super accurate prediction of what each idea will do. It's just to get a general idea. You're not going to know for sure how well each idea is going to work until you actually test it. And this will just help you weed out the obviously bad ideas. And you're going to do that for everything, or for all the ideas and requirements. The other thing that you need to do as part of this is rank each of the requirements. So you've already defined all your project requirements. Some of them are going to matter way more than others. And it's going to help if you rank those in terms of importance. You might find that some of them end up at the same level, or maybe there are gaps. Maybe you don't care at all about costs because you have a ton of money for this project, or you don't care about time or whatever. So ranking all of them is going to be next after that. But yeah, the important thing is at this point, it helps to have quantitative assignments for things as opposed to qualitative, just because as you're having the discussions about whether one idea is better than another one, it's an easier way to get across ideas to each other. If you say, I think this has a reliability of 4, as opposed to, I think this is pretty reliable, since you have a general idea of the scale. And again, it's just to help you keep from being stuck in one phase, spending 20 minutes talking about which idea is the best idea. Cool. So, oops. All right, so now we've got our scoring system, we've got some ideas. How do you figure out which one to go with? So we could just pick one and call it a day, but that's not really going to help you when you have to justify this for the final presentation. So that's where prototyping comes in. So you're going to select the top 2 or 3 ideas. The more time, the better. Actually, the more ideas you select, the better. Really, the only limiting factor with any of that is the time, the budget, and the people power that you have. You can always prototype more things, but I would recommend at least 2 to 3 ideas if you have the option for that. And as part of that, you should also identify what specifically you need to test. So basketball shooter, if we've got, let's get a few ideas for different types of basketball shooters. What do you guys have? How do we shoot a basketball?
First thing that comes to mind for me is kind of like how a human does a shot put. You can have a real simple spring-loaded mechanism that launches an actuator, comes back.
Collins and his springs.
Okay, nice. That's good.
Dropping
so
it.
like a shot put spring, like a pinball launcher sort of thing.
Yeah, sort of like that.
Yeah. Okay. So you got that.
Dropping it from above the hoop. Like we just have it on the ceiling and we just drop it in.
That's actually really smart. That's a good idea. Okay, so you've got the pinball launcher. We've got just dropping it from a fixed position over the hoop.
Potato cannon.
Potato cannon. So would that be like an air pressurized sort of system? Okay, so some sort of like pneumatic or air launcher. All right, so those are 3 totally different ideas. Cool. So as far as we can tell, those will all. Yeah. Or did you have something, Tyler?
Oh, I mean, trebuchet always comes in.
Trebuchet. Okay, there you go. So we've got 4, and then just round it out. Do you have one, Donna?
Yeah, I was thinking of more compliant material, like you bend it back and then it
Okay.
releases.
I like
Okay,
the
there we go.
stickiness in that.
Yeah. Okay. So we've got 5 totally feasible ideas, right? We've ranked them all. How do we know which one is actually going to be the best? Or rather, yeah. So we've decided we're going to prototype some of these. What exactly are we looking for here? Why would we need to prototype them? We want to make sure they actually score, right? We want to make sure that they hit that 80% reliability. At this point, we don't really have the control system or electronics figured out. There are a few options for how we can actuate some of those systems, but some of that may vary. So we just need to make sure that the concept itself can actually work and get at least around 80% reliability. So that'll help. The reason you want to figure out that sort of thing ahead of time is because your prototype isn't going to be exact to your final one. That's the whole point of a prototype. And it helps you figure out what the most important parts of that are, so you can make sure that your prototype still actually relatively accurately reflects what a final product might look like. Right. So as an example, if there happened to be a weight limit for the final design here, there isn't, but let's assume there was. You probably still wouldn't end up building it with the exact accurate materials depending on budget, but something like, say, we'll compare the catapult to the compliant sort of material. There's probably a lot more moving parts in the catapult. You're probably going to have a lot more mass there in general, whereas the compliant material, you've got the compliant material and then maybe something to hold it back to a specific distance. So although you won't necessarily get an exact final weight, you'll still have a good idea of how they compare to each other. And that's what you really need to do. You need to get an idea of how the ideas compare to each other, because you're trying to narrow them down to see what your best option is going to be. And as part of that, it helps to have a scoring system as well. I said it before, quantitative data always helps, and it's way better to make an actual comparison, especially when later on you have to justify your decision. It's a lot easier to say, well, we found that the spring-loaded plunger system worked with about 85% reliability, whereas maybe the catapult worked with 80% reliability. And it's easier to say that than, the catapult missed more times, or it seemed to miss more often, that sort of thing. All right, so now what happens if more than one prototype is tied for the winner? Which one do you pick? You're in a good scenario because you can just leave it up to a coin flip pretty much at this point. As long as all of the winners meet your minimum requirements, you've already proven that these are all totally viable ideas. So flip a coin, call your psychic, doesn't really matter. Pick the one that looks the coolest. So long as they all meet your requirements, and based on your scoring and how you've ranked all the requirements, if they're tied, then all of them should be good. What if only one of them met the minimum design requirements? That's pretty unlikely to happen. If that does happen, you might need to go back to brainstorming, just because you've probably missed some ideas, or you need to reevaluate your requirements. You might find out that they've been set a little bit too strict. But if those aren't the case, it's very unlikely that you'll get to this scenario. Yeah, and if you find that only one of them meets the minimum design requirements before you even get to prototyping, you're still going to want to test it, because you might find certain issues that won't come up. On top of that too, when you're testing and selecting prototypes, if you see we've got these 2 viable ideas, there's a third one that's okay, but probably isn't going to work, it still very much helps to test that third one, because it gives you extra context. It'll tell you how much better the 2 good ideas are, or you might find that third idea wasn't actually as bad as you thought, and maybe those first 2 ideas have some issues that you weren't expecting. None of our ideas met the design requirements. Now what? Figure out if your prototyping standards were too low. Did you miss something important that you needed to check when you were prototyping? Did you set your budget too low for that? You might have hindered the performance too much to actually meet your requirements. You can go back to the brainstorming phase, like I said. Maybe you missed some ideas. You might need to modify one of those concepts. So, for example, with like the flywheel shooter I mentioned. So maybe you tested it with, let's say, okay, so maybe for some weird reason you decided to actuate it with some sort of weird piston system, right? You got it to work, but that might not be as reliable as if you had used, just a direct driven motor or something else like that. So you might need to reevaluate how you actually prototype things. And then lastly, as I said before, reevaluate your design requirements. You might have set them too unreasonably high.
Brian, can I ask a question?
Yes.
This all seems very early on in the design process.
Yes.
So you're actually talking about like prototyping ideas as opposed to prototyping a final design.
Yeah, and the reason you want to do that, so let's say you skip the prototyping phase. You come up with all your ideas, you pick the one that you think is going to be the best idea, right?
Yeah.
So now you've come up with your design, you get to test. Oh shoot, you find that there's a problem that you totally not anticipated. And it's a big enough problem that you might need to rethink the design. You now have to go all the way back to a really early part of your phase, a ton of time that you just spent designing things, and a ton of maybe money you spent on that ends up not really working out. It's one of those things where it's better to do it earlier on, and it also helps when it comes to actually justifying your decision, because now you have a lot more context with the prototype. So you've instead of having one design that you picked and later on built, you now have 3 earlier concepts, and you have more context because this design this design worked, so did this one, but we know that the design we picked is the best one because it worked better than these other concepts for these actual reasons in testing. Does that make sense?
Yeah. And so what level of I guess like completeness should these prototypes be? Like, is it literally anything that you can throw together that's going to prove the concept or help prove the concept, or should it have some level of kind of standards to?
Yeah, I would say, it's part of that is just based on your time and budget. If you have more time and budget, then you can make something nicer, but really at the end of the day, it just needs to be something that has the same basic functionality as your final product. So, you can make it out of plywood and 2x4s. If it functions effectively the same way, then that's totally fine. Doesn't necessarily even need to be the same dimensions.
I guess I'm mainly asking, like, should it be to the point where we're like CADing out these things and having them 3D printed, or
it would be totally fine to do some of that. Just keep in mind that whatever you design and make there isn't necessarily going to be the actual final thing that you design. So you might not use any of those actual 3D models in the final one.
Okay.
Cool. I think one thing, kind of adding on to what Tyler was saying as well, is the way that this capstone program is designed, which, keep in mind, both Dr. Bridge and Dr. Collins despise it, is that we really only have room to take one design very far, the way the whole program is laid out, which is stupid and is why Dr. Bridge hates it, but it makes it a little harder.
Yeah, and the point with the way this design phase or this design process is set up isn't to take any of those specific designs super far. It's just to help. So, because after you have a ton of ideas, at some point you have to pick which one is going to be the best one, right? Or which one you think is going to be the best one. And you can only make that decision so well based on theoretical information. The point of prototyping is to get actual, like, real world information from testing something, so that you can know for sure this is what's actually going to be better. And a lot of the time you're going to find out that what you thought was going to work one way actually works slightly differently. And that's really important. So that's the whole point. So you're not going to take any of those designs, or you're not going to take all of those designs super far. You just need something simple enough to show, with actual numbers, this is the design that's going to be our best bet.
Okay.
yeah, so we're still pretty early on in the overall design.
And I apologize.
yeah.
I'm gonna have to run away. I have to get to work.
Okay,
I
no worries.
really appreciate your presentation. It's been perfect. Thank you so much, Alec. Excellent. Excellent. Thank you again, Brian. I really appreciate it. It was awesome.
Yeah, no worries.
Good to see you, Tyler.
See you later.
See ya.
Okay, so now we're at a point where we've tested. Oops, I skipped my slide over here. All right, we're at a point where we've tested a bunch of designs. We've figured out which ideas we know are going to be our best bet going forward. So you might think at this point, it's time to start designing. If you do that, though, it leads to a really big issue. It can lead to a really big issue, which if your design has multiple subsystems, which is poor system integration. And I've been on projects where this was an issue. It's surprisingly easy to start designing and then realize, oh, I built a structural piece where a motor needs to go, and there's nowhere else I can move this. So that's why it's really important to, before you even actually divide and conquer, to create a final concept. And this is where you want to sketch earlier on with your ideas, but you want to have at least one final sketch of how all of your different ideas integrate into one. The basketball shooter, that might not necessarily be too difficult because we don't need to move it around. But if there was a drivetrain, we need to figure out how to fit the drivetrain to whatever the shooter looks like, and we figure out how they actually connect to make sure that there's enough space for all the electronics and everything, and for the actual shooter parts within the drivetrain. So let's click to the next slide. So at this point, it's just a final concept. You want to try to only define the quantitative properties that are necessary to meet the design requirement. And the reason for that is actually figuring out the numbers, like specific dimensions for things, is the 3D modeling. That's the whole point of the 3D modeling and design phase, right? So you can start working on these in this phase, but if you do that, you're going to run into a situation where you're going to be stuck in the concept phase for a long time because there's always more dimensions to define. So the goal here isn't to get all the dimensions defined. You want to get anything important defined. So if you know that you have a weight limit, this is where you say, this is our goal for the weight limit. We're pretty sure we can meet this based off of what we learned from prototyping and generally how much things weigh. Or if you've got size limits, or like drivetrain, we want a drivetrain with this aspect ratio, that sort of thing. Just the most important things. And yeah, so once you've got that figured out, it's time to create subsystems and assign roles. You're going to want to assign subsystem leads. If your team is small enough, which this is probably the case, you might be your own subsystem lead. Right. Last thing is, it's important to schedule regular design meetings at this point. Since now you've actually got people working on individual things, you want a regular time to be meeting, to discuss any design updates, and just get general progress. This is going to be a point in your design phase where it's really important to communicate what your designs look like, because you need to be able to integrate them. So you need to, if your design needs to interface with someone else's design, this is when you have to talk to people and figure out how they actually connect. So let us review. So we've got, before you actually start with designing things, assign your project manager, assign your note taker, create a schedule your weekly update meetings. Then you can identify your design requirements, brainstorm, create your scoring system for your ideas and score your ideas, prototype your ideas that you think will work best, take what you learned from there, create a final concept, and repeat those as necessary. And I missed create subsystems and assign roles, but that's okay. That goes right below the final concept. Oh no, actually that's on the next flick. There, yeah. Yeah, so that's what we have so far. This is the most linear part of the design process. There's still a cycle in there that you can repeat, but from here on out, it gets a little bit more blurry and a little bit trickier to kind of figure out when to move to what part of it. So at this point, knowing all this, what would you do next? What are the next parts here? What do we have left to do?
Well, that's actually where we are right now, as a matter of fact. We have just broken up into 5 major subsystems. On Monday, we went over a little meeting on how they all integrate together. And we are currently breaking off into basically our own one-person subsystem groups and catting up some basic ideas for said subsystems. And our next meeting, which will likely be tomorrow is Sunday, so probably tomorrow evening, we will be looking at putting those together and then iterating each subsystem accordingly.
Cool. So it sounds like you're moving on to actual design work. What else is going to happen after that? What else do you need to do? Are you guys building anything? Cool. So you got to build, and then it sounds like you guys are planning to test as well, right?
Right.
Mhm.
Our first guy will be 3D printed. We have a couple motors. I got this motor that we can do fun stuff with from an awning.
Nice. Cool. So yeah, so those are the 3 parts of the next phase, but the problem is they're not exactly linear. They end up looking sort of like this. And the exact placement of these won't be exact. It'll vary very much depending on what your application looks like, what your project looks like. But there's a reason that this sort of happens. So let's say we do go through them in order. So we're going to design, a basketball robot or whatever. We're going to design the whole thing. Cool. So then after that, we're going to build the whole thing. And then after that, we're going to test it. You're going to find that some parts of the design are going to get done way quicker than other parts, especially because some parts depend on other parts to be done first. The same thing's going to happen with build. If you wait until your design is 100% done to order anything, you're going to be sitting around for a few weeks while your parts show up. And then same thing with testing. You can't have everyone around your final product at the same time testing it. So you'll have to take turns. And it gets pretty tricky. So the key is being able to stagger the different parts of those phases. And in actuality, this is a bit of a cycle because you're going to end up designing parts, building things, testing key parts of those. If you find there are issues, then you have to go back, edit your 3D model, and repeat that. So scheduling during this part is critical. I don't remember if I mentioned this before, but you should be at the end and start of every phase, you should be meeting again to discuss your schedule, because you're going to, getting to the end of that phase, you're going to have a better idea of what the next phase will look like. So you're going to want to update your schedule for that, account for any delays that have occurred, and make sure that you're still on track. So during this phase, it's especially critical because you're going to have to switch back and forth between different parts of that. It's going to very much help to have an idea early on of what is most critical for you to test. So if there's something you're concerned may not function correctly, that's something you're going to need to test very early on. So that's something you're going to want to prioritize first in terms of getting that design built and then tested. You also need to define criteria for when a design is good enough to move on from one phase to the next. So, you might not have all the, let's say that's a good example. It's kind of tricky to give an exact example. This is part of why this is such a difficult phase. It very much depends on your exact scenario. And you're probably going to make mistakes, but that's totally okay. That's why you document things. Then you don't end up accidentally making the mistake the next time. And the point is to learn. So I do have a few pieces of advice for when to move on to the next phase. A pretty good standard point is when you have about 80% of the 3D modeling done. That's a pretty good time to start ordering parts. And when I say 80%, that would be if you've got subsystems, for example, and you've found that you can compartmentalize that. If 80% of one subsystem is done, you can probably start ordering those parts for that, even if a different one isn't done. test any, like I said earlier, anything you're worried about not potentially working or that you need to make sure works exactly right is what you're going to want to test the earliest. If you can compartmentalize any of the builds or any of the testing if possible, do that. That'll very much help when it comes to efficiency. If you've got a small item, you can't have too many hands working on it at the same time. So if you can separate it into two systems and have two groups working on it, that'll speed up your build time. Same thing with the test. But most importantly, do not build or order anything until you've started your system integration. That's the most important part because that's where things will go wrong if they go wrong. Like at the very least, you need to have if you haven't already put together a master 3D model that has all the subsystems, put one together, slap everything in there, get everything in about the right place, and make sure that there are no interferences, make sure everything works together. Having your final concept as one drawing before you even get to this will help with that a lot, but that's super important because if the reason why things can go wrong with the builds and the tests is because you didn't integrate your system. So that's super important. Just making sure I miss anything. So after all that, you've got a final result, and it's time to figure out how good it turned out. Evaluating the final results is almost the entire point of documentation because it's going to tell you what your requirements were, how you went about doing things, and show you where you potentially made mistakes or where you can make improvements. So on paper, you can evaluate and look at how it actually met the requirements. You can run a test and see what the numbers are like compared to what you were hoping for. But what's going to help you actually dissect that is having that documentation. So when you can go back, you can see, where you potentially made mistakes. Take pictures often. You'll have the note taker for this, for pictures and note taking, but it helps if anyone can take pictures at any point or take notes at any point. The more documentation you have, the better. It sounds like it can be tedious, but it's way easier to just every once in a while take a picture here and there, write a few notes here and there about the thing, even if it's really brief, because anything can jog your memory. And I can't tell you how many times I've been working on a final paper for a project or a final presentation, and I'm trying to explain something, and I think, let me go see if I have pictures of that. I didn't take pictures of that because I didn't think it would be useful to have pictures of this partially assembled thing. Or other times when I'm trying to think, or I'm trying to explain something, and I look back and I see, I happened to take a picture of this when it was partially disassembled. This is the perfect angle to explain exactly what I'm talking about right now. So super important. Other thing that'll help with is if you work on a version 2 of your product, you'll now be able to go back and look at the past mistakes you made and hopefully avoid them in the future. And that's sort of the design process. Like I mentioned earlier, this isn't set in stone. It very much depends on the company you work for, the project you're working on, the people that you're working with. One specific implementation of it may not necessarily work in a different one, but hopefully this is a pretty good enough basis for you to be able to apply it to different scenarios. Some important takeaways. At a certain point, you can spend forever talking about how something could work or how something could be better or what design could work better. At a certain point, if you've, all else considered, at a certain point, you just have to try something. If you're stuck, nitpicking between two different ideas, you're not really going to know for sure which is better, if at all, until you try it. So if you're stuck on something, just try something. Worst case, you find didn't actually work out, and then you have this other backup plan that you can go with now. The first version of something is never perfect, so it's really important to temper your expectations. That's part of why defining your design requirements early on is really important. There's a lot, like we could make this robot have auto track for the basketball robot. We could make it have auto tracking. We could make it have like a really crazy drivetrain that works really fluidly. We could have tons of awesome features. It could have a battery that lasts for a year, but that's setting the bar really high, and it's important to have your requirements set early on to make sure that you're not designing something that is going to end up being like incredibly disappointing. So having your expectations separate is important, and having your requirements set early on is important. If you met the minimum requirements, you succeeded, because that's the important part. You did, you shot the basketball and you got it 80% of the time. And that's, yeah, you're going to find things to improve, and that's what version 2 is for. Document everything all the time. I said that already a few times. It's really important. It's going to make your job way easier later on. And it's one of those things where it's way easier if you just do it periodically than it is if you remember, I haven't written anything down for 2 weeks. What did I do on Monday last week? I can't remember. So that's why the weekly meetings I mentioned earlier, just to catch everyone up, are really important. And then also having regular scheduling meetings are important. And that is it. Oh, there's an extra slide at the end. Nice, I didn't remove this. Okay. Any final questions? I'll switch to...
So when you talked about assigning the different roles,
Yes.
Allie had an interesting idea where we will rotate through the roles so that everyone gets a, shared experience trying out different things. Do you think that's a good idea in order to let everyone have a chance, or do you think that might just overcomplicate things, and there might be, say, for the project manager handing that off, there might get stuff dropped in between that?
That depends on what the roles look like, I think. In general, I would say that would be a bad idea, just because you're probably going to end up with a lot of confusion in terms of actually keeping the project moving. That said, that doesn't mean that you can't have some some, I guess, overlap. That doesn't mean you can't have people kind of try a few things differently. Some of the phases or some of the parts of this are a little bit easier to do that with. So for example, with like if you have one person working on electrical stuff and another person working on, the mechanical for something, that's something that's a little bit easier, because you might be able to find one specific part of it that you can have that person work on. But some of the other things are a little bit trickier. I think you still want to have one person as the set person for that role. If you want to try to get different experience with the different parts of it, I would try to see if you can come up. How do I phrase this? You'll need to see if you can come up with like a small, a relatively small portion of that, or like an inconsequential portion of that, for example. I guess the best example I could think of is when you're on Trickfire Robotics. So I wanted to work on all parts of the robot, or like even in some small extent, both for experience and just because I thought it'd be cool to say I touched every part of it. I was able to. I didn't. Most of my focus was project management and then design work for the drivetrain. That's where my focus was all the time. But when it came to building the robot, I got to actually do some of the wiring and learn about some of that. Put together some of the electronics. I talked to the lead programmer and asked him to give me a small part of the robot that I could code. That was effectively like I didn't. I specifically didn't really care if he just told me specifically what to type in, but he ended up giving me something that required a little bit more thought, which was pretty cool. And it was something that wasn't a big deal. So he was still able to keep track of that, but I did some of the work for that. And then of course I was on build and design for that. So it's kind of tricky, because it is really great to get experience working on multiple parts of it, but at the same time, it's really, really easy to stall your project if you do that. So I would try, if you want to try to get experience with different parts of it, I would try to see if you can assign small, relatively inconsequential parts of that task out, and then they can work on that, if that makes sense. You guys have any other questions? Let me change my video. Oh, just kidding. That broke the video. Okay. There we go.
I mean, I suppose I'm in a position where I can just ask you later if I think of something.
Yeah, that's true. Yeah, if you guys have any questions at any point, let Jacob or Allie know, and they can pass them on to me because I live with them. Cool. So yeah,
That's
I hope that
awesome.
helps.
Allie, turn off your background, and then Brian can wave.
Oh yeah, I can actually. No, you'll see the secrets.
Oh no.
Hey.
That's really
Nice.
silly from that angle.
It is a green screen. I was wondering how you. I was thinking you must have
Yeah,
one. that has
I need better lighting because I couldn't get the colors right, and I'm still really foggy.
Well, thank you so much. That really crystallized
I-
a lot of the concepts for us. That really
I-
did help.
Mhm.
That's good to hear.